say raise your hand if you believe there is life outside of Earth. Yeah, like somewhere else in the universe. I don't want to believe I have to wake up in the morning, but I do. Okay. Well, they don't necessarily have to be. So you guys are an SRS, understood? An SRS. And SRS, you're 100 people also. An SRS of 100 people found that 40 of them I do believe. The DI or IU? I can't. Alright, I'll take it. Believe aliens exist. And then it would say construct and interpret and then they're going to give you a confidence level. So they might tell you 90, usually it's 90, 95, or 99. Those are the ones that are most common. But this number here is like, it's not the same every time. So I'm going to say construct and interpret a 95%. Confidence interval to estimate the true population proportion. So I've got my little sample. I'm trying to use this little sample to make inference, called inference, about the general population. Bigger picture. Because remember, that's just one sample. There's nothing special about it. The next person that takes a sample might get 50. The next one might get 25. You guys remember what that's called? What? Sampling variability. Variance is standard deviation squared. But those they sound really similar. Okay, so we actually did a lot of prep for this last unit. So we're gonna do the intro or state. So we're going to say P equals, because we're trying to estimate the true population proportion. That's what we're after. That's P. So P is going to be the true population proportion of alien truthers. And then we have to, this is like our thesis statement. We want to estimate P at a 95% confidence level. So based on my single small data set, I want to do the best I can to be like, okay, I'm 95% confident, not 100 on my mother, but I'm pretty darn sure the true answer is somewhere in between, like these two things. The next thing is the conditions. So we talked about like shape, center, and spread. What's the shape of this? How do we know? This is that big sheet you guys had. So basically, is it approximately normal or not? It is. But how do we know besides like it probably is going to be, so we can keep going? Yeah. So it's not the 30 thing, that's for me. No, n times p and n times q are greater than or equal to 10. So like 0.4 times 100 and 0.6 times 100 are both greater than or equal to 10. So then we are approximately normal. always thought those conditions were going away, but that was just the start. Center. Okay, so the mu is going to be what? The middle. So it's the middle of the sampling distribution. If you want to write it like that. What's my best guess? What's my point estimate? What's my 0.4? So the middle is 0.4 because the original was 0.4, 40 out of 100. And because I took an SRS and it's unbiased, I can assume the best thing I can do right now is assume that the true population is represented by this sample. It's probably not, but that's the best thing I have to go off of right now. So the center is this, and it's because we're unbiased, which is because we took an SRS. So this is like the randomness thing. And then spread, see if you can figure that out when I get Jason's equations. We're doing this. The blank sheets of paper. You guys coming from the same place? Is there a lot of tasks or something? Oh. And we're doing this, the blank sheet of paper after.
It's hard. I thought it'd be like center. We can't put it later.
Okay, the spread. We need independence. So that 100 has to be less than or equal to 0.1 times all people. And then that allows us to say, okay, now I know my standard deviation is the square root of 0.4 times 0.6 divided by 100. So this should look really familiar so far. This is, you're testing a lot of this stuff. So I got 0.049. So now I know we are approximately normal with a mean of 0.4 and a standard deviation of 0.049. And I've justified all of that. I justified normal, I justified the 0.4, and I justified the 0.049. So now I can do the math. The math is a little more annoying now, because you have to write out a little bit more. So let me, we're going to write it out in words, then we're going to write it out in symbols, and then we're going to find the actual answer. So in words, any confidence interval is going to be the point estimate plus or minus the margin of error. I'm going to write out this next line, like for your benefit for teaching purposes, but you don't have to write it when you're doing it. That is the same thing as saying point estimate plus or minus critical value times standard deviation. So you need one of these things. You do not need them both. This is a little more specific, like that's what we're about to do. The reason I'm doing this is because I want you to understand that the margin of error is equal to these two things, so just kind of like reinforcing that that's all the same. But that's like me writing it out in words. Now I'm going to write it out in symbols. So the point estimate It's P hat. That's the best guess I have right now. That's my sample proportion. Plus or minus, so the critical value comes up, and I don't know how much we'll have time to get into this today, but just write Z star for right now. Z with like a little star, like as though it was an exponent. And then the standard deviation is, I know it's 0.049, but this is, I have to write it in symbols. So I'm rewriting that PQ over N is how I found that. Then I'm going to plug in my numbers. So now I can say 0.4 plus or minus, I'm just going to tell you Z star because I don't want to rush that explanation. .96 times the square root of 0.4 times 0.6 over. Or you actually could have just put 0.049 there. So now, I've got to do 0.4 plus 1.96 times 0.049. That's going to give me my like upper bound. And 0.4 minus 1.6 times 0.049. So again, I'm writing out like more than you actually need to. So that number is going to be 0.4 minus 1.96 times 0.049. And that number is going to be 0.4 plus. So this is like your wiggle room. You get that amount of room in each direction. You got to go from the middle and figure out where those endpoints are. So I got 0.304. 0.496. So, are you on your mother's life ready to say that the true answer is somewhere in between those two numbers? I don't think so. You gotta be 100% sure. But I'm pretty close. I'm 95% sure. So again, what that means is if every individual one of you took your own sample, you wouldn't all get 0.4. Some of you would, some of you get something close. You work through it, maybe you got 0.35, 0.45, whatever. You get down to your confidence interval. You guys all did them. In theory, 95% of you would have the right answer in there somewhere. And 5% of you, it would be like outside. Because I don't know the real answer. Like, that's what's kind of weird about this. I never know the real answer. I just know, like, my sample, we're trying to guess the big picture, but I don't have any way of like proving it. So all I can say is this. And then we're going to conclude. Before I conclude, are there questions on how I got either of these two numbers? Yeah. Yeah. So the conclusion. So there wasn't a conclusion last year. We're just going to say we are 95% confident. What's up? Z star is a mystery until tomorrow. We don't have time. Plus, it's like a, leaves you on the edge of your seat.
I don't like that.
We are 95% confident that P, what is P?
0.4.
No, not 0.4.
True population proportion.
Yeah. So this is, we're 95% confident that the true population proportion, the real answer, is between whatever I just said, 0.304 and 0.496. And you're done. That's a confidence interval, like full worked out, showing all your work. Essay, I don't know what you want to call it. Some people at this point in previous years have been like, wait a minute, you always tell us, like, include context, like, tell me what's going on. I don't see any context there. And I would say there is context there, it's just hidden, because it's inside of the P. What does P represent? P is this, and that's context. So that's why we wrote it out right away, because then I can just kind of use P going forward, and I don't have to like keep writing and writing. So I'm sure there's questions. I'm sure that's not like all absorbed, but that's all we have time for today. We'll break it down more tomorrow. Anything I can't answer at this point? Okay, so that's just like an intro. We'll keep